x-axis. So we should be drawing a picture right now of the situation. The force F2 has a magnitude of 8 newtons, and its direction is 60 degrees above the x-axis. Determine both the magnitude and the direction of the puck's acceleration. Okay, so let's draw a picture. And in this problem, I want us to ignore normal and weight force right now. I just want us to focus on the applied forces. So let's assume normal and weight are not in play right now. Okay, so I have a hockey puck that's on ice, even though it's under the ice, but pretend that didn't happen. And I know that it is moving, just say we know it's moving this way, and there's 2 applied forces that are making it accelerate. So the one force number 1 was 5 newtons. So let's just call the middle of it is where my origin is. So I have 5 newtons, but that one's directed below, just kidding, it's directed below the x-axis. Okay, there's my axes. It's 5 newtons, 20 degrees below the x-axis. So here's my 5 newtons, and there's my 20 degrees. Okay, so there's one vector, that would be F1. My other vector, F2, was 8 newtons and 60 degrees above the horizontal. So that would be 60, and that one was 8 newtons. My goal was to determine both the magnitude and direction of acceleration. I want magnitude and direction. So I'm actually going to say A equals and theta equals because theta will tell me my direction. Okay, how do I do this? That's my picture. I've organized my forces in my diagram. But let me draw a free body just to simplify things a little bit more. So we know that's 60. And I know that's 20. I know that this one is 8 newtons, and I know that that one's 5 newtons, which is totally not to scale at all. Because actually 5 newtons is way longer than 8, that's okay. Okay, so let me break this up into components. But when I do that, I want us to start by thinking about what are the forces that are acting in the x direction, what are the forces that are acting in the y direction. So if I have components, I have to break my problems up this way. The sum of the forces, so I'm going to write sigma F sub x. Let's start with the forces in the x direction. The sum of the forces in the x direction are equal to, okay, what do I have? I know that I have cosine of 60 times 8 newtons for this top one. So what? I have 8 newtons times cosine 60 in the x direction, because I have, this is my 8 newton one, but in the x direction it would be this part, so it would be cosine of 60, if I think about that component. But I also have an x component of the 5 newton one, which would be, and that one is directed downward, so I would say a negative 5 newtons times cosine 20. If you didn't do the negative, you absolutely could have done, a positive 5 cosine negative 20, because that still would indicate direction, because it would have given you a negative number. So either one would have been fine, but it should have been, I'm sorry, not minus, positive. Thinking about the y. It'd be positive. Just kidding. Forget what I just said. Should be positive. Both are in the positive x direction. I'm sorry, I don't know why I said that. So 5 cosine 20, and then 8 times cosine 60. So the sum of the forces in the x direction is equal to, so 8 times cosine 60 would give me 4 newtons. And then 5 cosine 20 would give me 4.7 newtons. So the sum of the forces in the x direction is 8.70, I'm sorry, not 8.70, 8.7 newtons. 8.7 newtons. Okay, so I found the force. The sum of the forces, or the net force in the x direction. My goal is to find the overall acceleration, the magnitude of the acceleration. So if I know ax and I know a sub y, I could find the magnitude total of a, and then I could find the direction by taking inverse tan of the acceleration in the y over the acceleration in the x. So if I know the sum of the forces in the x direction, did they tell me the mass of the puck? I think they did. They told me it was 0.3 kilograms. So let me go ahead and find the acceleration in the x direction. So if I have the force, if I divided by the mass, it would give me acceleration. So 8.7 newtons divided by 0.30 kilograms. That would give me, is that 29? So a sub x is 29 meters per second squared. I want to do the exact same thing, but I want to do this now in the y direction, okay? Okay, so I'm going to do sum of the forces in the y is equal to, I have a y component of the 8 Newton one, so 8 sine 60, and now this is where I'm going to have my negative, because now this is in the negative direction for y. So then minus 5 sine 20. Okay, so this is the one you could have done plus 5 sine negative 20, or we could just do a minus 5 sine 20, okay? So 8 sine 60 would be, oh my gosh, what is that, 6.9? 6.9 minus 5 sine 20 would be 1.7. That's a terrible sigma. So the sum of the forces in the y direction is going to be equal to 5.2. And that would be newtons. So then to find the acceleration in the y, let's divide by the mass, 0.3. And that means then my acceleration in the y would be 9.2 divided by 0.3, 17.4. Okay, so I know my acceleration in the x, I know my acceleration in the y. Let's square both in square root to find the overall magnitude of acceleration. If I do that, I should get like 33 or 34. So let's just say it's 34 meters per second squared. And then if I want to know the direction, because that's the last piece, let's do inverse tangent of 17.4 over 29. And assuming that this is my picture, it should be